Guys. So first of all, I'm going to go through the distance formula. I'm going to go through it a few different ways, and then I'm going to explain what it has to do with what we've been talking about, and that's parallelograms on the coordinate plane. So I'm going to go through a few things. Because this is a review, you can skip through this if you think you know, okay? So if you know the distance formula and you know it well, you can skip straight through to this part, why it matters for parallelograms, okay? So I'll try and pause on each one of these pages. So I'm pretty much going to break this down into 4 parts. What it is and how it's just a Pythagorean theorem. How to do it using just the formula itself. So if you're looking for just the formula, how to use the distance formula, which I'll go ahead and I'll write here, is distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so if you just want to use the formula, so if you're a plug and play kind of person, use this. I'm then going to explain how it's just, you can do it by counting boxes and the advantages and disadvantages of that. And then most important for us, why it matters for parallelograms. Okay, so if you want, you can fast forward to the part that you think you need. Okay, if you want to watch the whole thing, it really shouldn't take us all that long. All right, so first of all, the distance formula, okay? This is the distance formula, okay? All the distance formula asks us is essentially, hey, if I give you this line, right, how far is it between this point right here and this point right here? And there's more than one way to do this problem, okay? We can do it by counting boxes. We can do it by just plugging in numbers. What's important for us is that it's just the Pythagorean theorem, okay? When we're doing all these, whether we're doing it from the graph or whether we're doing it with the actual formula, all we're really doing is saying, hey, what is, let me do it in a different color, what is this distance right here and this distance right here, okay? And by doing that, we create a little right triangle, right? We're going to create a little right triangle, and what that's going to allow us to do is we're going to say, well, this is kind of the x direction, and this is kind of the y direction, and we know that this squared plus this squared equals this squared, right? So we know the Pythagorean theorem is a squared plus b squared is equal to c squared, right? So we know that a and b have to be the two small sides, and c has to be the longer side, okay? All we're saying, though, in this case is that we're not going to call them a, b, and c. We're going to call them x, y, and d, right? So really what the distance formula is going to tell us is that x squared plus y squared is equal to the distance squared, okay? Now, how do we actually find these distances? How do we find x, y, and z? Well, again, from our points, from this point, let's give them a name. We'll say this is some point x1, y1. Now notice that those are subscripts. Those aren't exponents. That's just saying this is point 1. This is x1. This is y1. I'm going to give this one another point up here. This is x2, y2. So these are two different points. This is x1, y1. This is x2, y2. Well, let's think about this for a second. If I want to find this distance, d, right, I also need to know how long is this side. Well, if you notice that this point right here is actually, if we take a look at it, has the same x coordinate as this one up here, right? I went over 1, 2, 3, 4 boxes. So this is 4, 1, and this up here is 2, 3, 4, 5, 6. This is 4, 6, right? So this point has the same x coordinate as this point, right? And this point over here has the same y coordinate as this one. If you see, they both went up 1 box. So this is actually the point x2, y1. So if I wanted to know this distance right here, well, how do we normally find the distances? We subtract, right? This distance right here would be x2 minus x1. And I'll show you with the numbers in a second. So it'll be x2 minus x1, right? That's this side right here. This side right here is x2 minus x1. And this going up and down is going to be y2 minus y1. Well, very easily, if I kind of get rid of these for a second, well, we said that this bottom side right here, right? This bottom side was x2 minus x1. And this distance right here is y2 minus y1. So what do we know? Hi, babe. My wife is home. That it's those two sides squared is equal to the distance squared, right? A squared, b squared, c squared. Now, what throws a lot of people off is we have this huge square root sign. So in order to get the square root sign, all we're really doing is the same thing we know. How do we get rid of the squares? How do we get the square next to the d? Take the square to this side. We take the square to this side. So what do we find out? That the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, sorry. So let's plug some numbers in here real quick just to show you. All right. So this point over here, -3, 1. This point over here, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. And this point over here, right? What is this? This is 1, 2, 3, 4, 1. So just to show you that, yes, this does make a nice right triangle, right? And we do know that this distance right here is going to be x2 minus x1, right? So if you think about that, what is that? x2 was 4, and x1 was -3. So 4 minus -3 is 7. Now, could you just count in the boxes? Yeah, of course. 1, 2, 3, 4, 5, 6, 7. We'll get to why that is a little bit more dangerous of a route to take. And over here, again, what's this? This is y2 minus y1, or 6 minus 1, which is 5, right? And again, 1, 2, 3, 4, 5. So let's look at our distance formula. We said it was the square root of x2 minus x1 squared plus y2 minus y1 squared. Well, again, what did we say that was? We said that that was the square root of 4 minus -3 squared plus 6 minus 1 squared. Okay? 4 minus -3 is going to be 7 squared, like we said. 6 minus 1 is going to be 5 squared. Okay? 7 squared is 49. 5 squared is 25. So the distance is equal to the square root of, what is that, 74. So whatever the square root of 74 is, and I'm sure you can break that down. That's not really our concern today. We'll get to that later, okay? But what's the distance between these 2 points? This is the square root of 74, whatever the square root of 74 is, okay? All right, let's take a look at a couple examples. So I'm going to move on. Using just the distance formula, so just the numbers. So say I gave you the following numbers. Say I give you the numbers, I'm going to give you the point, oh, I don't know, 0, 4, and -7, -5. Well, again, what are you going to say? You have to decide which is point 1 and which is point 2. I'm going to say this is point 1, and this is point 2. Okay? It doesn't matter which one's which. You can call this one x1, y1, and this one x2, y2. It doesn't matter. You just have to make sure this is your first point, this is your second point, or this is your first point, and this is your second point. You can't be mixing and matching the numbers, okay? So let's plug it in. What's x2? Well, x2 is -7 minus x1, which is 0. Okay? Over here, what's y2? -5. What's y1? 4. Okay? Again, negative 7 minus 0, well, anything minus 0 is just itself, right? So this becomes negative 7 squared. Negative 5 minus 4 is going to be negative 9 squared. Okay, so your distance, negative 7 squared is going to be 49. Again, it should always be a positive number that comes out here. Plus 81, and your distance is equal to the square root of, what is that, 90, 130? Okay, and you can stop right there. It's the square root of 130. No big deal. No big deal, right? We'll do one more that way. Okay. I'm going to give you guys the point. Say I gave you the point. Let's go 0, 10, and 8, 6. So again, this time I'm going to call this one point x1, y1, just to show you guys it doesn't matter. x2, y2. It doesn't matter which one you name which. Okay. So what will we say? x2 in this case is going to be 0, and x1 is going to be 8. So 0 minus 8 squared. What's y2? 10. What's y1? 6. 0 minus 8 is going to be negative 8. 10 minus 6 is going to be 4. Negative 8 squared is going to be 64. 4 squared is going to be 16. 64 and 16 is going to be 80. So your distance is going to equal the square root of 8. Now, just for a moment, I do want to say that you can simplify this if you're asked to. If you said, what's the square root of 80? Again, if we wanted to put it in simplest radical forms, which is something we've gone over, what's a perfect square that goes into 80? We know that 16 times 5 is equal to 80, right? So we could break this down into radical 16 times radical 5. Radical 16 is going to be 4, okay? So if they ask for in simplest radical form, you can go over that. If you have a hard time with those, I'd rather save that for a separate video because we still got a few more things to get through today. Now, what if they give you 2 points and you just wanted to count the boxes? So let's go over the same example we just went over. So what if I gave you the points 0, 10, and 8, 6? Well, 0, 10 is right up here. And 8, 6 is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, right? And again, if we wanted the distance between these 2 points, you can just kind of count it like slope. I can just say I went down 4 and over however many points, right? So I could just say I went down 1, 2, 3, 4. Remember, it's a distance, so even though we're going down, it's still 4. It doesn't matter. I went over 1, 2, 3, 4, 5, 6, 7, 8. So again, if we were thinking about this as a slope, this is a slope of negative 4 over 8, or negative 1/2. But we can't reduce our distances like we reduce our slope, okay? So again, though, well, what could you do here? You could just say, well, I know that the distance is equal to the square root of 4 squared plus 8 squared, right? That would definitely speed up your process a little bit. So you can just count the boxes, but there is a danger to this, okay? So the distance is equal to the square root of 80, which we said was 4 radical 5. There is a danger to this, and that is that what if you got numbers that were very, very large, right? What if I told you that the numbers were, I don't know, let's go with something. What if I told you the numbers were 347,007 and I don't know, 451,736, and I want to know the distance between these 2 points. Well, graphing is not going to help you, right? Then you have to use the distance formula. So I do just want to caution you guys that if you have very large numbers, or what if I said it was this? What if I told you it was 5.753 and 2.78, 7.9, and those are your points. Those could be your points, right? Graphing is not going to bail you out. So if you want to understand it conceptually through the graph, that's fine, but you can't totally rely on it. You're going to have to know how to use the Pythagorean theorem and the distance formula, okay? So let's do one more. Say I give you the points 4, 7, and 0, 4. Okay? 4, 7, I got 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. I got 0, 4, which is 1, 2, 3, 4. Okay. Again, let's count it like slope. I went up 1, 2, 3, and I went over 1, 2, 3, 4. Well, again, most of you guys should know at this point, then what's the distance between these 2 points? Well, say 3, 4, 5 right triangle, right? So rather than do all the math, you could just kind of count the boxes and say, all right, well, even if you didn't know there was a 3, 4, 5, well, I know that distance is 3, and I know that distance is 4, right? So your distance would equal 9 plus 16, which is the square root of 25. And again, we only want the positive square root because it's a distance, right? Now notice here, I switched the x and y in here. It doesn't matter. It doesn't. If you're going to count it like slope, as long because you're adding, it doesn't matter which order you add. Okay. All right. Who cares, right? So why is this important for us? Okay. If I said, hey, what kind of shape is that? Right now, you know it's quadrilateral, right? It looks like it's a parallelogram. It looks like it might be a rectangle or a square. It looks like it might be a rhombus. I'm not really sure. Well, what can I do to figure this out? And this is where this becomes a very useful thing to be able to do the distance formula. The simplest thing you can do for this is to go ahead and see this right here, right? That I can compose a square around it. And if you notice, this is a 1, 2, 3, 4, 5, 1, 2, 1, 2, 3, 4, 5, 1, 2, 1, 2, 3, 4, 5, 1, 2, 1, 2, 3, 4, 5, 1, 2. So if we notice this, and again, why this is going to be important for us the next week is that if this is 5 over 2, and this is 5 over 2, and this is 5 over 2, and this is 5 over 2, it doesn't even matter that we actually have to do the distance formula. The fact that we see they're all 2's and 5's, we know that 2 squared plus 5 squared is always going to equal the same number squared. So it doesn't even really matter, but again, it becomes a very useful tool that we can find those distances. But in a lot of cases, we're not even going to need to be able to, we're not even going to be required to find it. If I could, again, show you this one up 5 and over 2. Well, first of all, you know if this one up 5 and over 2, and this one went up 5 and over 2. First of all, you know that they're parallel, but you also now know that they're the same length, right? Because you know that your distance between them is going to equal 5 squared plus 2 squared, right? So I mentioned to you guys the other day that in some cases you're going to want to use slope, and in some cases you're going to want to use distance. It really depends on your preference and the situation and the information that you are given, okay? So this is going to matter for us because we're going to be able to show that size of the same length. Not only are they parallel, but they are the same length. And there's going to be some ones that are a little more complicated than this, and we'll get to that. But I just want you guys to kind of review and understand the Pythagorean theorem and the distance formula in order to get this. So again, what does it show us? That this is 5 over 2. So this is, 5 squared and 2 squared. Well, that's the square root of 25 plus 4. So your distance is equal to this, whatever the square root of 29 is. But because these are all 5's and 2's, what do we know? We know, therefore, that this is, these are all the square root of 29. Right, which is good. That tells us it's a rhombus. But again, also knowing that this is up 5 and over 2, right? So what's the slope here? It's 5 over 2. Again, what's your slope here? Down 2 over 5. Well, I know these are negative reciprocal. So the distance tells us that these are all the same length, and our slopes tell us that these are perpendicular, okay? So again, I'm going to give you guys some distance formula problems to do. You can go ahead and you can do them however you choose. If you want to graph them and then just count the boxes, yeah, break out a sheet of graph paper and do it, no problem. If you guys want to just plug in numbers and get the answer, that's fine too, okay? Let me know if you guys have any problems. If you guys need to go over the simplifying radicals again, we can do that as well, okay? I hope this helped you guys, and I will talk to you later.